Hi everyone. I'm going to try to give you an example on the closed interval method. So I have a function f defined on a closed interval ab, and we say a point c is a critical number of the function if the derivative of the function at c is 0 or the derivative does not exist. So we say c is a critical number if f prime of c is 0 or f prime of c does not exist. Where are we interested at critical numbers? Well, so here I have a function. We have a local minimum at c3, and we can see that the derivative at c3 is 0. So normally when we have a local minimum or a local maximum, that is at a critical number because the derivative is either 0 or the derivative does not exist. Okay? Well, so do we have any other kind of critical numbers? Here's a critical number c1 in my graph here, where the derivative is 0. Okay, the tangent line is horizontal, you can see that, but c1 is not a local max or a local minimum. Well, to find the absolute maximum or the absolute minimum, well, as you can see here in this example, the absolute maximum is at a boundary point, and the absolute minimum is at an interior point at a local minimum. So when we have a continuous function, well, where do we look for an absolute max or absolute minimum? We look for the absolute maximum or absolute minimum either at a critical number or at a boundary point. So the method that we're going to see here, called the closed interval method, says that when we have a function f continuous on a closed interval, we have to have an absolute max and we have to have an absolute minimum. It does have an absolute max and an absolute minimum. So this gives us a recipe on how to find this absolute maximum and absolute minimum. So the first step is to find all critical numbers, say c1 and c2 and on and on. Well, how do we find them? We look for the derivative of the function, set it to 0, and solve. That gives us some of the critical numbers. And also we see if the derivative does not exist. That also gives us critical numbers. And then next step is to compute f of c1. Oh, I'm sorry about that. I don't know what this is. Alright. So, okay. So the next is f prime of c, no, not f prime. So what we're going to compute is f of c1. How much? F of c2, on and on. We also compute f of a. You see why I pre-typed my video, because it's really hard to write in this thing. So after we calculate f of c1, f of c2, f of a, f of b, and all the functional values at each critical number, then the largest is the absolute max and the smallest is the absolute minimum. That's as simple as that. So there's 3 easy steps. First, find all the critical numbers. This involves finding derivatives. And then once we have the critical numbers, we don't need the derivative of the function, we need the original function. Find f of c1, f of c2, f of a, f of b, and all of those functional values at each critical number. Then the largest, absolute maximum, the smallest is absolute minimum. It's as simple as that. Now, I have an example that I want to show you. So here's a function f. It is a polynomial, so it's defined on all r, but we want to know the absolute maximum and absolute minimum of the function within the interval from -2 to 2. So the first step is find all critical numbers. Okay, let's find critical numbers. Critical numbers. To do that, get the derivative of x. That gives you 3x to the third minus, no, 3x squared minus 12x plus 0. I'm going to leave that off. And now set that to 0, f prime of x equals 0 gives you 3x squared minus 12x equals 0. Factor 3x, that gives you x minus 4 equals 0. That says x equals 0. That's what you get from setting 3x to 0. Okay, that's x equals 0, and x equals 4. That's what you get when you set x minus 4 to 0. Okay, set x minus 4 to 0 gives you x equals 4. Now we're supposed to have those two critical numbers, and let's see if we have more. More meaning where the function is not differentiable. Well, this is a polynomial, so it's differentiable everywhere. So we don't have any more critical numbers. Now, the next thing to see is whether each critical number we found is within the interval. Well, you can see that 4, although it's a critical number, is not in this interval. So what we're looking for are the critical numbers within the interval from a to b. In this case, from -2 to 2. So we don't need x equals 4. Okay, so we're going to work with only 0. Okay, now this next thing to do is compute f of a, f of b, and f of the critical numbers. In this case, f of 0. Okay, f of a is f of -2. That's -2 cubed plus minus 6 times -2 squared plus 5. Okay, that gives you -8 minus -2 squared is 4. 4 times 6 is 24 plus 5, and that gives us -32 plus 5 is -27. Okay, and now that's f of -2. F of 0, I like to work from left to right, so I have -2, 0, and 2 to look at. Okay, f of 0 is 0 cubed minus 6 times 0 squared plus 5 plus 5. That gives you 5. Okay, and f of 2 is 2 cubed minus 6 times 2 squared plus 5. That's 24. 8 minus 24 plus 5. That's 8 minus 24 is -16 plus 5 is -11. 11. Okay. Okay. Now we're almost done. Okay. So what are the functional values we've calculated? Lost my pointer. Okay, there. So one of them is -27, and the other one is 5, and the other one is -11. So what's the local max? I mean absolute max. So step number 3 says absolute max is 5. Well, it is at, we're not sometimes interested in where it's at, but it is at 0, at x equals 0, and absolute minimum is -27 at x equals -2. -2. Alright, so that's the absolute minimum, and that's absolute maximum. Well, that's it. Thank you, and have a nice vacation. I will see you on Monday. Alright, bye-bye.